So we can't hear you. It's not. Sir?
Oh, okay, okay. Uh, now I am audible.
Yes, sir.
Am I audible?
Yes, sir.
Oh, sorry. I forgot to. So suppose uh, today we have to study matrix representation of a linear operator. So first of all, we define linear operator. Suppose T is a linear transformation from vector space V to vector space V itself. Then T is called a linear operator, right? T is a linear transformation from same vector space to same vector space. Then we call T the linear operator. So now let us take one basis. Suppose my basis elements are U1, U2 in this way up to UN. This is basis of V. Let us denote basis by S. So now if I take U1, then its image under T is TU1, and because my codomain is an element of V, my codomain is an element of V, so I can write TU1 as a linear combination of U1, U2 up to UN, right? So see, I write in general TUI is a member of V, therefore I can write TUI, I can write TUI as a linear combination of basis elements. Linear combination of basis elements. Right. So suppose I choose U1, so TU1, it is a member of V, so I will write, because S is a basis, so V is spanned by S, means every element of V can be written as linear combinations of UI. So I will write this as A11 U1 plus A12 U2, and in this way up to A1n UN. Similarly, if I pick U2 and take its image under T, I will get an element TU2, and because again it is an element of V, so I can write it as a linear combinations of UIs. So I write it as A21 U1 plus A22 U2 plus in this way up to plus A2n UN, and in this way I will write up to TUN, and TUN can be written as AN1 U1 plus AN2 U2, and in this way up to ANN UN. Now what I will do, I will take the transpose of the above matrix of coefficients, which we call matrix representation of T. So I am taking all the coefficients and I will take its transpose, right? And that is called matrix representation of T. So matrix representation of T is denoted by T, and if your basis is not clear, then I will write the basis symbol here, so that if there are more than one basis, so you can show your basis which corresponding to which basis you are writing linear transformation like this, or you can omit if it is clear. So I will write all the coefficients column wise because I have to take the transpose. So A11, A12 in this way. A2 way up to A2n, A1, A this way up to A. So this matrix is called matrix representation of T. This matrix is called the matrix representation of linear operator T. The matrix representation of linear operator. Okay, is it clear to all of you? Is it clear?
Linear operator T.
Please tell me loudly. You are not audible.
Nothing
Please
clear,
tell me.
sir. Clear, sir.
Okay. So now we will present this concept using example. Okay. So I will take few examples in order to make you understand the linear transformation. So let us suppose that F is a mapping from vector space C R square to R square. So it is a linear operator. So let F from R square to R square be a linear operator defined by Fxy equal to, see, I am writing 2x plus 3y, comma 4x minus 5y. 4x minus 5y. Then my question is to find matrix representation of F related to the basis S, where S is given by U1, U2, where U1 is 1, 2 and U2 is 2, 5. Okay, so this is the simple setting, and we have to find matrix representation of F with respect to basis S. Now, see
So,
what I will do. Tell me, please.
like, what is like value for U2? Like 2, 3.
1, 2, 2, 5.
Okay, so
I'm just writing clearly. Now it's right.
yes, sir. Now,
Okay. Now, now see. First of all, I find F image of U1, right? And then I will find F image of U2. This is the first task. And what is the second task? As soon as you find F image of U1, you write it as a linear combination of U1 and U2. So how to perform this task? You first see F image of U1 means U1 is 1, 2. I put here x is equal to 1, y equal to 2. So what order tuple I am getting? See, 2 1 ja 2 plus 3 2 ja 8. 8 plus 2, 3 2 ja 6 plus 2, 8, right? 2, then 4 1 ja 4 minus 5 into 2, 10. So minus 6. So you are getting 8 minus 6. So I'm writing this as column wise, right? I'm writing this as column wise. And I have to write this as a linear combination of U1 and U2. So I have to write this as a linear combination of U1, which is 1, 2 and 2, 5. So coefficients I will give as x, y, and our aim is to find x and y for which the left hand side is equal to right hand side. And it's extremely simple. See, x into 1x, y into 2y. So x plus 2, this is my first component, and it should be equal to 8. Similarly, x into 2x plus 5y. So 2x plus 5y, this should be equal to minus 6. So I got a system of equations. How you will solve this system of equations? Please tell me. How you will solve this system of equations?
We can substitute value.
No, don't do that, because you are now in BTech courses. Don't apply methods which were taught you in your standards 8 or 9. Don't do that. You just apply Gauss elimination or Gauss-Jordan method, right? So now you form the augmented matrix. So I write the coefficient of x is 1, coefficient of y 2, right hand side 8, then 2, 5, right hand side minus 6, right? And now we row reduce it. So first of all, I have to make this element 0. So I am multiplying first row by minus 2 and I will add it to second row. So 1, 2, 8, and see, minus 2 plus 2, 0, here 1, 8 to just 16, minus 16 and minus 6, minus 22. So I got minus 22. Next, what I will do, I have to remove this one. So I multiply minus 2 to the second row and add it to the first row. So I will get 0, 1, minus 22, and here 1, then minus 2 plus 2, 0, and then minus minus plus 22 into 2, 44, plus 8, that is 52. That is 52, right? So I got 52 and minus 22. So here I am substituting. See, what is x? X is 52. What is y? Y is minus 22. And this is my u1. This is my u2. So with this, I can write f u1 as 52 u1 minus 22 u2. Right? Is it fine? 1 minute. हाँ सर बोलिए. Hello, am I audible?
Yes, sir.
Yes,
Yeah.
sir.
See, next step, same type of operations we will perform with U2. So what I have to do, see, I have to find F image of U2, and that I have to write as a linear combination of U1 and U2. So U2 is what? U2 is this much. You can see U2 is 2, 5. So what I will substitute? I will substitute here 2 and 5. Okay. So x2. So 2 2 are 4. 5 3 are 15. 15 plus 4, 19. And here 4 into 2, that is 8, minus 5 into 5, 25 minus 8, minus 70. So minus 70. Okay. So what is FU2? FU2 is 19 minus 17. Okay. FU2 is 19 minus 17. Now I will write this as a linear combination of U1, 1, 2 and U2, 2, 5. And again, I will write here xy, and our aim is to find xy. So let's see again, x into 1, that is x, y into 2, that is 2y, and that should be equal to first component, that is 19, and again x into 2, 2x, plus 5y, y into 5, 5y, and that should be equal to minus 70. So I got my system of equations. And once I got my system of equation, I will apply Gauss elimination technique. So x plus 2y, I will write the coefficient 1, 2, 19 and 2, 5 minus 70, right? And in order to make clarity of right hand side, I can put a line. So now see here what I can do here. See, I will multiply minus 2 to first row and add it to second row, right? So I will get 1, 2, 19, and here you can see minus 2 plus 2, that is 0, minus 4 plus 5, that is 1, and 19 to the 38, minus 38 minus 17, that is minus 55. Okay, and then what I have to do, I have to make this element 0. So what I will do, I will multiply second row by minus 2 and add it to first row, right? So at the same time I will get, see here, 0, 1 minus 55, and here 1, and minus 2 plus 2, 0, and 15, 55 into 2, 110 plus 19, 129. I got 129. So I got my x. X is equal to here. X is equal to 129, 129, and my y is minus 55. So and this is u1 and this is u2. So I write 129 u1 minus 55 u2. So I write all the coefficients. So matrix representation of f is, see, 52 minus 22, 52 minus 22. So I will write 52 minus 22 and then 129 minus 55. And this is your required matrix representation, right, of. Is there any doubt? Is there any doubt in the process? Am I audible?
Yes, sir. No doubt.
No
Please.
doubt. Okay, then I'm shifting to next question. Okay. If you have any doubt after class also, you can ask me. Okay. Don't hesitate. So see, my second question is, let V be the vector space of functions having basis. Let V be the vector space of functions with basis S equal to, see, my basis is sin x, cos x, and e to the power 3t. Then for differential operator D, which is defined from V to V, right? I have to find the matrix representation, and D be the differential operator, D be the differential operator. Find matrix representation of D. Find matrix representation of D, right? And see how much simple. You have to just apply simple steps. Let's have a look. See, first of all, what is the image of sin x under D? See, D of sin x. D means differential operator. So when you differentiate sin x, you will get cos x. And I have to write this as a linear combination of these three elements. So sin x because no sin x is present, I will put 0 coefficient. Cos x is present with coefficient 1, and because no e to the power 3x is present, I will put 0. Similarly, d image of cos x. So d means derivation. Derivative of cos x is minus sin x. I will write minus 1 into sin x plus 0 cos x plus 0 e to the power 3t. Next is e to the power 3t. Next is, so when you take d image of e to the power 3t, so what you will get? If you differentiate, you will get 3 times e to the power 3t. So 0 into sin x plus 0 into cos x plus 3 into e to the power 3t. Now, from here, I can write matrix representation of d. All the coefficients, I will write column wise. So 0, 1, 0, minus 1, 0, 0, and 0, 0, 3. Right? 0, 0, 3. This is your required matrix representation. Is it clear? Is it clear to all of you?
Yes.
So now see, I have given you one theorem which you can remember at this time. For any linear transformation T from Rn to Rm, there exists an m by n matrix A such that T image of x is equal to Ax, right? For all x belongs to Rn. Now we are talking about linear operators. So let us take T is a mapping from Rn to Rn. Then there exists an n by n matrix A such that Tx is equal to Ax for all x belongs to Rn. Right? Because we are talking about linear operator. So in case of linear operator, the domain and codomain should be the same. Right? So from here, you can see a matrix can also be viewed as a linear operator, and hence it has a matrix representation. So what we can see here, that because T is a linear transformation from Rn to Rn, but you can see here that Tx is equal to Ax. So you can view matrix A as a linear operator, and hence it has a matrix representation. So let us see how to find a matrix representation. First of all, let us take my matrix A as 3 minus 2, 4 minus 5. 4 minus 5. And the basis I will take as U1, U2, where your U1 is given by 1, 2, and your U2 is given by 2, 5. So what I have to do, see, we are finding T image of x. So here we will find Ax. So first of all, I find Ax. A is 3 minus 2, 4 minus 5, and x is my 1, 2. X is my 1, 2. And from this, what I will get, see, 3 into 1, 3, minus 4. 3 1 are 3, minus 4, minus 1. 4 1 are 4, minus 10. That is minus 6. All right, I will get this thing. And now this vector has to be written as a linear combination of U1 and U2. So 1, 2, it is U1, and 2, 5, it is U2. So I have to write it as a linear combination of U1 and U2. And as such, here it is required to find x and y. See, x into 1 is x plus 2y. So I write x plus 2y. This is the first component. It should be equal to minus 1. and then 2x plus 5y, 2x plus 5y, this should be equal to minus 6, right? So now again I have system of equations. I will try to solve it. 1, 2, minus 1, 2, 5, minus 6. So what I will do, tell me. First of all, I will multiply minus 2 to first row and add it to second row. So I will get 1, 2, minus 1, minus 2 plus 2, 0, minus 4 plus 5, 1, minus minus plus 2, minus 6, minus 4. Right? And again, you can see what I can do. I will multiply minus 2 to second row and add it to first row. So 0, 1, minus 4, and again here see 1 and 0, and minus 4 to the 8, minus 1, 7. I will get 7, 4. So x is equal to 7. Here you can see x is equal to 7 and y is equal to minus 4. Right? So it is 7u1 minus 4u2. This is your u1. This is your u2. Here, u1, u2. Okay? Is it fine? Now,
Yes,
next, I will here I have to write AU1. Now I have to find AU2. So what is my A? A is 3 minus 2, 4 minus 5, and U2 is your 2, 5. U2 is your 2, 5. So I will write 2, 5. So let's multiply 3 to just 6 minus 10. I'm getting minus 4, and 4 to the 8 and 25. 25 minus 8 is 17 minus 9. I'm getting minus 4 minus 17. So I have to write this as a linear combination of u1 and u2. So x12 plus y u2 is 2, 5 by 2, 5. Okay. So from this I will get my system x plus 2y, x plus 2y equal to minus 4, and 2x plus 5y, 2x plus 5y equal to minus 70. Now I have my system of equations. I want to solve this. So again, I will apply Gauss elimination technique. Right? So I will write the augmented matrix 1, 2, minus 4, 2, 5, minus 17. Right? So see here I have 2, so I will multiply minus 2 to first row, add it to second row. So 1, 2, minus 4, and minus 2 plus 2, 0. Here minus 4, 5 minus 4 is 1. 8 minus 17, 17 minus 8 is 9. So minus 9. Okay. Now what I have to do, I have to make the element above pivot as 0. So I multiply minus 2 to second row, add it to first row. I will get 0, 1, minus 9. And see here 1 minus 2 plus 2, 0. 18 minus 4, that is 14. Right? So 14 minus 9. So here you can see that x is equal to 14, y equal to minus 9. This is your u1, this is your u2. So you have 14 u1 minus 9 u2. So now I can write the matrix representation of a matrix, and that will consist of the coefficient 7 minus 4 as first column, 7 minus 4, and second one, second column 14 minus 9. 14 minus 9. So this is my matrix representation. Is it clear to all of you?
Yes, sir.
Any doubt?
Not as of now, sir.
Okay, so let's take one more example. let F be a mapping from R square to R square defined by see f of xy equal to 2x plus 3y, 2x plus 3y and 4x minus 5y, 4x minus 5y, right? Then I have to find matrix representation of S where S is given by U1, U2 and U1 is my 1 minus 2 and U2 is my 2 minus 5. 2 minus 5. Okay. So this is my question. Why I am giving this question? It will become clear to you in just 2 or 3 minutes. FS. Right? See, this is the same question as that of previous question. Right? But we will solve this question in some different way. Right? We will solve this question in a different way. Because we will try to find the formula for transformation and it will help you to achieve your answer in relatively simpler steps, right? So how it can be done? See, I am just going to find a formula. See, any element AB, right? Any element AB can be written as linear combination of U1 and U2, that is 1 minus 2 plus y2 minus 5 using which formula? So from here you can see it is x into 1 is x minus 2x, x is multiplied to each component, again y is multiplied to each component. So 2y minus 5y. Okay, and this is equal to AB. Okay, so from here what you get, see, if you add first component you will get x plus 2y, and if you add second component you have minus 2x minus 5y. Okay, and this is equal to AB, and from here you can see A equal to x plus 2y and your B equal to minus 2x minus 5y, right? You have A equal to x plus 2y and B equal to minus 2x minus 5y, right? So first of all, see what we have to do. If you find F image of U1, how much you will get? Or do one thing, you solve this pair of equations in order to find xy. So what you can do, you can write 1 here, 1, 2, right hand side is A, minus 2, minus 5, right hand side is B, right? And see how much I am getting. I am multiplying 2 here and adding to the second. So 1, 2A, 2 minus 2 is 0, 2 to the 4 minus 5 minus 1 and 2A plus B, 2A plus B, right? I will get this. I multiply minus 1 see what we can do.
Multiply second row by 2.
Why it will help?
Then we can add to first row, like multiply 2 and then 8. then we get value of x and y.
Okay, that we can do. So same task we can perform, because I want to make here +1, right? So I have to multiply first -1 there, right? And then we have to perform the remaining steps. Or you can, anyway, that's all right. See what I will get. 1 2a, if I multiply -1, I will get 0 1 minus of 2a plus b, right? 1 I got. Now pivots are 1. I want to make this 0. For that I am multiplying -2 to second row, and I will add it to first row. I will add it to first row. So see what I am getting. I am getting 0 1 minus 2a plus b, right? And when I multiply -2, so -2 plus 2 is 0, minus minus plus, minus minus plus, 2 2 to the 4a plus a, 5a plus 2b, 5a plus 2b. I will get this. So what is my C? X. What is my X? X is 5a plus 2b. And what is my Y? Y is minus of 2a plus b, right? So see, you can find xy in terms of AB. You can find xy in terms of AB. So what is the beauty of this? See, what is the beauty of this? So you can write your AB in terms of this, using this u1, u2, using this. This is your u1, this is your u2. So AB is x times. See, AB is your x times. X is 5a plus 2b times u1. u1 is 1 minus 2, 1 minus 2, and then plus y times. So here minus is there, minus 2a plus b times u2, and u2 is 2 minus 5. It is 2 minus 5. 2 minus 5. Right? So this way I can find. So this is the formula for expressing AB in terms of linear combination of u1 and u2. That is 5a plus 2b times u1 minus 2a plus b into u2. So in terms of u1, u2, I can write. Now, see, once you do this, your answer is simple. First of all, you find f image of 1 minus 2, right? So I will put 1, y equal to -2. So I put x is equal to 1, y equal to -2. So 2 1 are 2, 3 into -2 -6. So it's coming -4. And here 4, 4 1 are 4, minus minus plus, 10 plus 4, 14, -4, 14. So you have here -4, 14, right? Or you write column wise or row wise, doesn't matter. So let's write row wise. It doesn't matter. -4, 14. I will write -4, 14. And you have a equal to -4, b equal to 14. So when you substitute the values of a and b here, so 5 into -4, 5 4s are 20, and 2, 14 2s are 28. 28 minus 20, that is 8. So I am getting 8. So it is 8u1, 8u1, and then minus minus, see here if I will put 2a, so 2 into minus 4, minus 8 plus b, that is 14.
Minus 6 U2.
Minus 6 u2. Am I right? Then you find f image of another vector u2. u2 is 2 minus 5. u2 is 2 minus 5. So 2 minus 5. I will substitute here in the definition of f. I will substitute here 2 minus 5. And let's see what I am getting. When I substitute 2 1 ja 2, minus 15, so I am getting minus 11. 2 2s are 4, 15, minus 11, and here 4 2s are 8, minus plus 25 8 33. So minus 11 33. I am getting here minus 11 and 33, and I will substitute these values here. I will substitute these values here. Okay. So what I will substitute? I will substitute a equal to minus 11 and b equal to 33. So how much I am getting? See, I am getting 11 u1 minus 11 u2. And therefore, matrix representation of f relative to the basis is 8 minus 6, 11 minus 11. And you will get this thing. Let us verify that it is correct or not. Let us verify. So now it's simpler. You have to perform the steps only one time. You have one conversion formula, and using conversion formula, you can do this thing. So these are the things by which you can find the matrix representation of a basis. Next class, I will discuss properties of matrix representation by which we will get change of basis formula, and ultimately we will have some nice results about similarity. Okay, so next class we will discuss change of basis formula and similarity. Any doubt?
No, sir.
Yeah, please.